So, all right, let's get started here with the tubing. So we're going to identify various types of HVACR tubing and piping to determine which type of tubing is used in a particular application. We're going to identify the various types of tubing, piping used in hydronic and plumbing areas to determine which type of tubing is used in a particular application. There's differences between the two. We have to know which type is best for the application we're going to be using it in. So, we want to keep that in mind. All right. And then we're going to explain the proper cutting techniques for various types of pipe and tubing. Explain the proper bending of copper tubing at various angles using the correct tools without crimping the tubing. We want to make sure that we bend the tubing. We have nice smooth radiuses. There's special tools for that. If we don't, we're going to kink it. If we kink the tubing, we're going to have a restriction. And a restriction means that we're not going to move the heat out of the space as properly. All right, there's a blockage. It's almost like having another metering device in there. All right. Explain how to connect soft copper tubing using, well, it says glare fittings, but it really should be flare fittings, and soldering procedures. All right, and explain the proper procedure for connecting various types of pipe. So we have different types of refrigerant tubing. We have ACR copper tubing, which is air conditioning rated. All right, we want to use copper tubing that's air conditioning rated whenever we're working with refrigerants. Refrigerant pressures can get extremely high, so we want to make sure that this tubing is capable of holding up to those pressures. On our systems, traditional systems, we generally will pressure test to 150 psi. The manufacturer will, on the data tag, will tell you what the recommended pressure level is for testing to make sure that there's no leaks. We braze in, we connect all of our connections. We're going to pressure test afterwards. We're going to make sure that nothing leaks, and we also want to make sure that the copper is strong enough to not just explode. On some mini splits, the manufacturer is going to want you to test up to 600 psi to make sure that everything's intact. There's other systems out there. If you're running, I think I want to say ammonia, it can get up to like 800, 900 psi. So we want to ensure that whatever tubing we're using is going to withstand the pressure. Okay. We're not going to just grab any old copper pipe that we have and start brazing and say, call it a day. Stainless steel tubing, it's used in environments that are prone to possibly corrosion, copper corrosion, or environments like food places, factories, that sort of thing. They'll use stainless steel, and they're going to use it for like ammonia, things like that. Aluminum tubing, we're starting to see coils that are being made out of aluminum. If the coil's made out of aluminum, it's one thing, and you're brazing on, they'll have connections for you, usually going from aluminum to copper, that sort of thing. If the manufacturer's giving it to you, I'm okay with it. The one thing I would be scared of is any type of aluminum line set. All right, we have to connect our evaporator to our condenser. All right, the evaporator is going to sit over the furnace. The condenser is going to sit outside. We need to have copper tubing to connect the two. What we're going to use is exactly what it's called. It's a line set. It's a predetermined length you can get at the supply house. It's going to come pre-insulated for the vapor line, and they're going to come in usually about 10 to 15 foot increments. So I may be able to buy a 15-foot line set, so it'll come with both the liquid line and the vapor line. I can get a 25, I can get like a 35, I can get a 50, I want to say 75, 100, depending on where I'm working. They'll come in various lengths for the application. The other thing too is you have to make sure that when we're connecting to the condenser's able to pump very far distances. Certain units, they just can't pump very far. So if I try hooking up a 200-foot line set, I may have issues. All right. So ACR copper tubing, it's soft and it's hard drawn. All right. Stainless steel tubing is resistant to corrosion, and it's in food processing applications. All right. Picture on the left is going to be our ACR tubing, and then we've got the stainless steel on the right. You can get it hard drawn, meaning comes in sticks or 10-foot lengths, and then you would just put like a coupling on here to connect them, whereas we've got the soft tubing here, which we just uncoil. All right, aluminum tubing often used for evaporators, some newer heat exchanger designs. So like I said, if we're going to use it for an evaporator, we're good to go. If you see it as a line set, run away. So copper tubing does have different wall thicknesses, all right? K is an indicator of a heavy wall, and we also have L, which is medium wall. So when we're talking about doing plumbing lines, we're going to use an L type of copper, okay? If we're sweating in a water heater, that sort of thing, we always want to use the medium wall thickness. If you have heavy wall, that's okay too. The medium wall is indicated by like a blue labeling, blue numbering on it. So if we go back to the previous slide, you can see that this can be considered an M wall. All right, it's got that blue labeling on it. There's also M rated, which is red. M is usually frowned upon. You generally don't use that. That's usually used for a lot of like do-it-yourselfers. It's available at the store, but as professionals, most municipalities are going to require for you to use an L. They just want that thicker wall. All right. ACR tubing is specified by the outside diameter. What that means is if I want a 7/8 ACR tubing, well, the outside diameter of that is going to be 7/8, as opposed to if I were to get a 1/2 inch L copper tubing, well, my inside diameter is going to be 1/2 inch, all right, whereas the outside is going to be 5/8. So we have to keep that in mind when we are working on different applications. The reason they do this is so that way, if you were to try to use just traditional copper, just medium wall type L, and you're trying to put that into an ACR application, it's just not going to fit just because of the difference in size. So we've got the OD and the ID. All right, so keep that in mind. OD is the outside diameter, ID is inside diameter. All right, so we have annealed copper to make tubing soft and flexible. All right, so we apply a little bit of heat, it anneals it with the process, allowing it to bend and become flexible. All right, it's sold in rolls and it's difficult to recoil. So that roll that we saw back a few slides off on the right, right here, all right, this is really easy to uncoil. The problem is you're not going to be able to coil that back up. All right, so make sure if you're going to use a certain amount of it, let's just say I have a 20-foot roll, but I only need 10 foot. Well, I'm just going to unroll 10 foot. Using smaller diameter copper, 3/8, 1/4 inch, it's fairly flexible. You may be able to recoil it if you needed to, but if you get into the 3/4, 7/8 distance or the size, forget it. You're not going to uncoil that. That stuff is very thick and very big. Okay, it can become work hardened by oxidation or repeated bending or hammering, and can be softened by annealing, yet again by applying heat. All right, the annealing process. We're going to wear thick gloves and eye protection. We're going to hold tubing in a vise or insulated pliers. We're going to light a torch, adjust the oxygen for a blue flame. We're going to heat the tubing to a dull cherry red and allow the tubing to air cool slowly. We don't want to ever dip the tubing into water. That's going to shock the metal, which can make it brittle. So we always want it to just cool naturally. All right. Copper is going to cool very quickly just because it's able to dissipate the heat through the material in itself. So we don't have to sit there for hours waiting for it to cool, like a piece of steel, for example. So keep that in mind. All right, we just have some tubing lengths and coils. Okay, just some application, some data that's stamped in here. So this is a type L tubing. It looks like it's 1.25 inches. It's stamped on the side right there. and then it says 1 3/8 OD on the side right there. That's actually really nice because it'll tell me exactly what size that tubing is. If I need a fitting, or maybe I grabbed the wrong stick, here you go, look at the label, it's going to tell you that. The coil, unfortunately, doesn't have any labeling, so there's no information on there, so you just have to either measure it, or as you work in the industry long enough, you'll be able to pick up a coil or a roll and visually see that it's a 3/8 or a 1/4 inch or whatever other size. The other thing too that this one says, it's nitrogenized, all right? And what that means is they actually fill this entire tube full of nitrogen. So there's no impurities in there, there's no oxidation that forms. The nitrogen is going to keep that copper nice and clean inside until it's nice and ready to go. They fill it with nitrogen, they put in a plug, and once that plug is inside there, it's going to keep it all nice and tight. When you're ready to use it, pull out the plug, nitrogen escapes. It's an inert gas, it just blends in with the atmosphere, and we're going to go. All right, we also have hard-drawn ACR tubing, supplied in 10 and 20-foot lengths. The 10 is manageable, 20 foot is extremely long, so if you're working on a commercial application and you're going over long distances, you may use that 20-foot length. Supplied in same diameters as soft ACR tubing. So if I need to connect a tubing or something and I need some flexibility, I can use that coiled up tubing to make it work. All right. The nice thing about the hard-drawn ACR tubing, needs few clamps or supports. Because of the length of it and the stability and the rigidity of it, I can put on less support clamps, say if I'm hanging it from the ceiling. Should not be bent, all right? Cannot use flared connections, use straight lengths and fittings to redirect at different angles. So unlike ACR tubing where I can bend it, I can use tools to bend it, I can manually bend it up until, like I said, we get to that 3/4, 7/8 size, then it just becomes extremely difficult to bend. The hard drawn, we're going to have to use fittings on those. We're going to use fittings like we would on a traditional water piping system. We're going to use 90s. We're going to use couplings, that sort of thing to make our connections. Whereas with the ACR, I can just bend it into a 90-degree turn and make my connection. I can't with the hard drawn. Should be brazed and not soldered. And that goes for ACR tubing as well, okay? Whenever we're making connections, we want to braze and not solder. The difference being, brazing, we're using a higher temperature to really get the filler material to melt, and once it melts, it provides a stronger connection. Soldering, it's at a much lower melting point for the solder, and so we don't have as great of a connection. Improper brazing or handling techniques of tubing can develop leaks. All right, we want to make sure that we are careful when we handle our tubing. All right, if we drop it, we may get a pinhole inside the tubing, and we're not going to realize that. And if we bury the tubing behind some walls or whatever the case, well, guess what? We may have some issues, and we may have to tear apart that wall to get to that leak. All right, closely following proper handling and brazing procedures will minimize weak spots and reduce possibility of a refrigerant leak. Nobody wants a refrigerant leak, okay? That's the worst thing. When you do all this work and you go to fire up the system, there's some testing we do beforehand, and we find out that, you know what, hey, there's a leak somewhere. Now we have to go find it. Where is this leak? And if we just put in 200 feet of line, well, that's a long set of line to be looking for a leak. Okay. We have the non-refrigerant tubing and pipe used for water, drain, and vent lines. We have copper water tubing, plastic pipe, and steel pipe. It's not used to circulate refrigerant within an HVACR system. The type L, the type K, those are going to be indicators of the wall thickness on our piping systems. So we can have the type L for refrigerant, and we can also have a type L for our domestic water. We have to be careful when we're buying them. So if we go to Home Depot or Lowe's, we're going to have big old stacks of tubing that's just sitting on our shelves. That's designated as water tubing, all right? We can't use that for refrigeration. If we were to go down the line a little bit and there's some coils, you may find that the coils, the soft copper, is actually meant for ACR. I do know that they carry like a 1/4 inch copper ACR rated, and so we can use that if we need to. Yet again, the ID, the OD aren't going to match up, and so we're not going to be able to use the same fittings that we would with a copper water tube that we would with a refrigerant one. You may also find some plumbing fixtures, some sewer lines may be done in copper. You may come across it, but yet again, we're not plumbers. We are HVAC technicians, and so there's various uses. We also have plastic pipe. We can run into that. It's called PVC. There's also like a polypropylene. So there's different types for different applications. Okay, and steel pipe we know about. All right, copper water tubing we're never used with refrigerants. It's not thick enough. It's not meant for that application. Okay, heavy wall K used in severe corrosion conditions. Medium wall used in normal conditions. Okay. Yet again, we've got that type N, but they're not going to even talk about it because we shouldn't even be really using it. All tubing, valves, and fittings ordered by their nominal size. All right, so we can look over here. Our nominal size is 1/4 inch. We're talking about the inside diameter in this application. It's not really a 0.25, but it's close, you know, I guess for their standards or whatever the case may be. 0.305 for a type K, and then a 0.315 for a type L. We can see that the outside diameter is the same, the 0.375 for both. So the wall thickness does take up a little bit of the inside diameter on the type K. Okay, and of course there's our difference, the 0.35 versus the 0.03. So, all right, let's move on. We also have the plastic pipe, does not corrode, scale, rust, or pit. It's resistant to bacteria, algae, and fungi. So we've got ABS, used for drainage, waste, and vent piping. Off to the right is the ABS. All right, it's a black type of pipe. You may or may not come across it in the HVAC field. I haven't really seen too much of it here in the Chicagoland area. We really stick with the PVC, and PVC is the white stuff. All right, it looks just like the ABS, but it's white. All right, we're going to use that a lot of times for our venting of our furnaces. Okay, we could also use it for cold water supply, drains, fresh air inlet, and exhaust applications. The catch is with PVC, and there's talk of almost eliminating it. Once we start getting above about, I think, about 140 degrees, the piping starts to deteriorate. Okay, and so in certain applications, we're really pushing the limit of PVC for our exhaust coming from the furnaces, and so the international mechanical bodies that govern all the mechanical codes for us, they're really starting to say that we should go to polypropylene. It's got a much higher temperature resistance before it breaks down. It's closer to the 200 degree range, and so we may start to see changes. If you have polypropylene, awesome. You know, there's nothing wrong with that. PVC, we have to be careful that our system isn't running too hot and having issues. CPVC, it's a off-white, yellowish type of plastic piping, and we use that for cold and water lines, drains, some furnace venting applications. I never see CPVC being used for venting. All right, it's either PVC or polypropylene. And then there's steel pipe. It's used to circulate ammonia in some refrigeration systems, primarily used for gas lines or water lines. We'll have a black pipe or we'll have a galvanized pipe. All right, the galvanized sort of looks like a silvery color. It's a black pipe that has a anti-corrosion coating on it, and so a lot of older homes have galvanized pipes in there, and it's supposed to keep the pipe from rusting out. The problem is the galvanic corrosion just wears away over time, so you still get rusty pipes anyways, so it really defeats the purpose. If you have an older home, not many people are going to spend the money on repiping the home, so it is what it is, but traditionally we'll see copper as our main water lines here. There's also PEX out there, which is a flexible type of plastic hose. That's really frowned upon in the Chicagoland area, but it is out there, and they use like a press fitting to make the connections. All right. But back to steel, it cannot be bent, flared, or easily cut, joined using threads and threaded fittings. So what I'm going to have is I'm going to have threaded fittings that are going to connect the steel pipes together. All right. We're going to put sealant on the threads. We want to make sure that the material that we're trying to transport doesn't leak through, whether it's natural gas, whether it's water. We want to put something on the threads, whether it's a Teflon tape or a thread sealant, like a pipe dope. Something has to be on there. When they manufacture the threads for these fittings, nothing is completely precise, and so there's little gaps that are in between the grooves of both the male and the female ends, and so gas or water or anything else could potentially leak out. So we want to fill those little nuances in with some type of sealant. All right. Steel pipe is measured by the inside diameter, just like our copper tubing, or we're measuring the ID for it. All right, we've got the galvanized, which I said, used for water, and the black pipe, used for gas. We have a couple of ways that we can cut it. Hacksaw, wrong. Don't ever use a hacksaw to cut it. What's going to end up happening is when you use a hacksaw, you're going to leave jagged edges on your tubing. It's not going to fit in very well. There's potential for little burrs to be inside there that can break off. Just use a tubing cutter, all right? It's small, it cuts the tubing nicely, it cuts it square, which is even more important, all right? There's a little couple of roller wheels here. The tubing would sit on the roller wheels. We would press in the cutting wheel just to make a little bit of contact onto the tubing. Using the tightening knob, we would make a rotation. We would tighten it slightly to apply more pressure, and we would continue doing that, repeating the process until we cut all the way through. Once we do that, there's a little bit of a bevel inside. We pull out this little reaming blade and we spin it inside to remove that little lip that we just created. And that's going to make for a nice, smooth pathway for whatever substance we're trying to move. Especially with refrigerant, it can cause some turbulence and issues inside there. All right, use it, and here it is. Use a tightly secured sharp cutting wheel, measure and mark, hold tubing against rollers, align cutting wheel with measured mark, tighten, press the cutting wheel against the mark, and then rotate the cutter around the tube, gradually increasing the cutting pressure. And this is just what it looks like. Cutting, I should just delete this slide. I'm not going to even cover it. All right. Whenever cutting a tubing or cleaning a tube end, do not allow fillings or chips to enter the tubing. What that means is sometimes we're going to be cutting upwards, sometimes we're going to be cutting downward. We want to make sure that if we can, none of the little chips that we create or shavings from deburring fall in there. If they do, now all of a sudden they can become part of the system and they can plug up some type of orifice in there, whether it's a piston or one of the tubes inside the evaporator. Who knows? There's a lot of little nooks and crannies that a piece of copper shaving can hide in a refrigeration system. So it may cause a restriction or even cause valve damage. We want to definitely avoid that at all costs. All right, squaring and reaming the tubing end. We want to make sure that after the tube has been cut, we're going to have these like little bit of a lip just coming inside the ID of the pipe. All right, we don't have our refrigerant flowing through as we'd like because it would hit this little notch and just cause a little bump. So they say, file the tubing. If you're using a tubing cutter, honestly, you can just use the reamer. You put it inside. You're going to spin it around until we remove this little lip that's inside. And now we have a flat, square piece of tubing. Bending tubing, all right. Maximum radius for a 90-degree bend equals 5 times the tubing diameter, all right. Basically, if you're going to be bending tubing, you're going to use a tubing bender. If you're using a tubing bender, you're going to be able to tell once we reach that 90-degree mark. You can also pick a point here, measure it out to maintain my squareness. We don't want to go past 90. I've done it. As long as your tubing bender allows it to, you'll be fine, but the book wants you to keep it at 90. All right. Or you can also make a U shape here for different applications if needed. And that's just telling you what your guidelines are. Half-inch tubing should be at least 5 inches minimum distance apart if we're making that type of a bend. There's also a bending spring that we can use. I'm not very fond of the bending spring. Never used it, but it's sort of, it doesn't really work as well as they advertise. It does help, but there's other tools that you can use. I think I showed you guys one of them was the ratcheting bender. That does make bending tubing that much easier. Another thing that I didn't even show you guys, but it's really cool. Let me see if I can find it. Is the let's see if it'll come up. This stuff. So this comes in smaller diameter, so you can't really use it on traditional systems. But if we're doing mini splits or we're working on, let's just say 3/8 line, you'll always have a 3/8 line, or usually have a 3/8 line when we're installing a system. This plastic tubing actually goes inside of our copper line set. And what ends up happening is once it goes inside, it creates a point where I can bend my copper similar to with the hand bender, but it's internal. So I'm not going to kink it. If I do bend it too much, that plastic piece isn't going to want to come out. So I may have to unbend it slightly, but it's really nice if I have a lot of little twists and bends or nooks and crannies to cover. I can use one of these guys, the Easy Bend Bender Kit. Like I said, they're only good from 1/2 inch to 5/8. So, 1/2 inch to 5/8. No, it should go down to like 1/4 and 3/8 with the correct kit. But up to 1/2 inch and 5/8 is the max on it. 3/4, 7/8. Yeah, that, like I said, that stuff just isn't going to bend too easily. We're going to have to use a ratcheting bender for that. Or you're going to have a manual type of bender. And so this is just illustrating how to use it. We're going to insert the tubing to the desired mark. We're going to slowly apply pressure, and as we apply pressure, it's going to rotate around the mark, giving us the desired type of bend. There's little notches here, so that'll tell you exactly where to stop. Once this little mark aligns with whatever degree you want, you know you're done. So real easy to do a 90-degree bend. So we have flared connections, okay? We also have solder connections, braze connections, and suede connections. To the right is a flaring block. This is the traditional way of using this tool. All right, or creating flares. We're going to put in a piece of copper inside here, where the copper is going to stick out slightly above the top of the block. We then have a cone shape tool that's going to come down and it's going to push down onto the copper tubing, creating a flare for you. This is nice and great, but it does take a little bit of time because I have to get my tool to perfectly align with the top of the copper, make sure everything works like it's supposed to, so you can get it a little bit cheaper than the 642, but real simple. You just put this little front piece onto the copper, you twist on the gun, you press your buttons, and you're done. Takes you literally 30 seconds as opposed to this guy, which will probably take you like 5 minutes to do. And if you're doing tons of flares, that adds up very quickly. The other thing too is when we are making our flaring connections, we have to make sure that we put a nut on first. If you put the nut on, or we need the nut on to be able to push that flare connection onto the connector, and we do that using threaded nut connection. If you forget to put that nut on there, well, you're going to have to cut that flare off and redo it. Doing it with the traditional way, using the flaring block, you're going to be miserable, you're going to be pissed because you just spent 5 minutes for nothing. Now you're going to have to do it again. I'm not even mad anymore when I do this. Just get forgetful, cut the tubing off, the flare off, put the tool on, you're done. Start all over again. We have a single flare. It's a 1-layer or single thickness of tubing, and it's usually at a 45-degree angle with SAE fittings. And then we also have a double flare, which doubles the tubing thickness. It's a stronger flare, and it's recommended for larger size tubing. I've never had to do a double flare, so I wish I could tell you more about it, but on the residential side, never needed it. So this is the single flare illustration, basically, or this is a flaring illustration, I should say. On a traditional flare, we would just use this tool. It would press out and create this 45-degree angle on our tubing, and we're done. But if we want to create a double flare, we have to use this little adapter. We push down, we create a little beveled area, and then the tool will come down and create a stronger connection. Okay. These are our flare fittings. This is the flare nut I was talking about. The flare nut is going to go onto the copper tubing first. We make a flare. That flare is going to sit on this portion of this fitting. It's got a nice beveled shape to it, which matches that 45-degree angle of the flare. And then that nut comes on, tightens down, and we're able to make a nice connection. If we're creating a flare connection, we have to torque it down to the manufacturer's specifications. The manufacturer is going to tell you how tight to make it. All right, what you consider tight may not be tight for me, or what my tight is may not be tight for you. So how do we know what is tight? Well, there's a tool, it's called a torque wrench. You put it onto actually, let me just pull one up for you. So here we go. This one's just a digital one. Basically, it comes with a adjustable head for different size flare nuts. Inside here, it's going to tell you, you're going to be able to adjust it based on what the torque recommendations are for the manufacturer, whether it's in foot-pounds or it's in newtons, whatever you're working on. This will tell you when you've reached that specific torque. So if I want to set it for 15 foot-pounds, I adjust the knobs to the right until we hit 15 foot-pounds. I then put the wrench onto my nut. I start to tighten. As I start to tighten, these little, up at the top here, there's little LED lights. They start to indicate what level I'm at. There's also an audible alarm. It'll finally beep once I reach that torque setting, and I don't have to physically look at that number to tell me I'm right there. So once I'm set, I know that my fitting is not going to leak, all right, or it shouldn't leak. The other thing too about making flare fittings you should be aware of is you want to use refrigerant oil. You want to put a little bit of refrigerant oil on the face of this. You're going to put a little bit on the front and the back of the flare itself. And the reason being is we have metal surfaces. We put a little bit of lubrication on there to keep it from binding. Sometimes that flare may bind to the metal surface here, which may cause it to kink or twist slightly, and you're not getting the proper torque. If there's some lubrication on there, you'll be able to spin the flare nut on there without really any issue. We also have other ways of connecting tubing. First is soldering. It's used to join water pipes and drains, and the temperature required to melt filler alloy is below 840 degrees Fahrenheit. So I'm going to use a propane torch. You probably see them in the stores. Comes in a little blue bottle. I may even have a yellow bottle. It's got a little head to it, and I can get a flame out of there. That's what we use for water applications. Okay, we're going to use that to make our connections. Whereas with brazing, we're going to use something that's a little bit hotter. All right, that propane torch, that MAP gas isn't going to get hot enough, so we need to use something a little bit better, an acetylene or an oxyacetylene torch. Those are going to provide the temperatures high enough to melt that filler metal that we have, and that's going to create a nice strong connection for us. Okay. Usually the temperature is below the melting point of the fitting in the tubing, so we're going to get that copper nice, hot, and red. And if we're not moving our torch around, we may actually melt a hole inside of that. So we want to make sure that when we are brazing, or even soldering for that matter, we're distributing that heat and we're moving that torch head. It doesn't have to be super hot, but gradually, we're keeping it away from just one place. All right, we have oxyacetylene brazing equipment, and that mixes pure oxygen and acetylene, produces a hot flame to braze quickly, and reduces heat transfer to tubing. The longer we apply heat to tubing, the more chance of damage that we have. So we have service valves that are close to the braze point on our condenser, and if that area gets heated way too much, we have these little gaskets that are inside, and they're going to melt. All right. If they melt, I may not be able to open up my service valve, or refrigerant may start leaking out. Okay. The other setups we have are oxypropylene, air propylene, air acetylene. All right. We heat that area up really quickly. We apply our filler. We're able to leave the site without damaging anything else potentially, if we're to use something like a MAP gas. All right. So here we are. All right. This is the propane. Here's the MAP, and then there's just the oxygen. All right. Most homeowners, they're going to have the propane or the MAP gas, and they're going to sweat their copper lines for their different applications inside their home. All right. And then we have something over here. It almost looks like a air acetylene setup. We can have a mixture inside that's going to be partially air, partially acetylene, We have a regulator up at top. We're going to be able to adjust our pressure, and then we have our torch head here, different fittings for different applications. All right, more heat, less heat. This type of torch head would just fit right onto the top of one of these guys. All right, oxygen, that's going to be a mixture. I think that's there's special kits that actually use this red bottle, so you're not going to just use oxygen by itself. All right, so here's our torch kit. All right, what we're going to do is we're going to mix oxygen and acetylene together to create a nice hot flame for ourselves. Then the hot flame is actually going to reduce our brazing time because we're going to get that surface nice and hot, which is going to melt our filler metal without potentially cooking that service valve or anything else in that area. All right, we've got the regulator on both the oxygen and the acetylene bottles. The regulator is going to reduce the pressure inside the bottle to a manageable amount for us. These bottles can be filled up to 2,000, 3,000 psi, so we have to regulate the amount of pressure of the gas coming out. All right, we've got a little carrying handle so we can carry both these bottles and both cylinders. We've got our goggles. You should wear some type of eye protection because that flame can get pretty darn bright. All right, we have our cutting torch here. The cutting torch we're going to use when we're cutting through metal, and if we need something hot, we're going to make something very hot and we're able to melt that metal and cut it away. For brazing applications, we're going to use this guy, a little rosebud type of tip. We're going to get just a little bit of oxygen acetylene flowing out of this guy, and that's going to be perfect for most brazing applications. If we need a hook torch tip, what ends up happening is we get flame that really comes around about halfway to 3/4 of the way around a piece of copper, so we're getting a nice equal flame. And in order to start everything on fire, we need to use a little striker right here. It's a little flint piece that's inside there. It creates a spark and we're able to light the gas. All right, phosgene gas is a byproduct of some refrigerants when they are exposed to an open flame or extreme heat. Flow refrigerant recovery procedures and practice to reduce contact with phosgene gas. Phosgene gas is like a mustard gas. You should be careful about brazing with any type of refrigerant in the system. All right, not only do we have, if we were to have refrigerant in the system, would we have a high pressure, but we also have the potential to burn that refrigerant. If we burn that refrigerant, depending on the refrigerant type, we may introduce a deadly gas to us, all right? Nobody wants to be breathing in mustard gas. With that being said, I actually read an article not long ago. It was actually really informative. And back in the day, this was absolutely true with different types of refrigerants that they used. But even with the advent of R22, you're not going to create phosgene gas from that, okay? Do we still want to, heat up refrigerant? Absolutely not. But the dangers of actually creating a phosgene gas from modern equipment is almost nil. So just something to share with you guys, so you're not potentially scared of the phosgene gas when you're brazing. All right, use a flashback arrestor with oxy-fuel. Most of the gauges and everything are going to come with a flashback arrestor. All right, what that is that's just going to prevent the flame from getting too far into the line if something were to happen, potentially exploding the rest of the flammable fuel that's inside those tanks. Okay. We want to make sure that we have a nice neutral flame when we are brazing. All right, we want to control the amount of oxygen acetylene coming out, and we can do that at our gauge head or our torch head. And so when we do that, we're going to make sure that we have a nice bullet-shaped inner cone, and we sort of have this purplish bluish flame, all right, according to the book. All right, if I have this bright blue flame, all right, I may have just an oxidizing flame, which I don't want. All right, and same, I don't want this carburizing flame where I have this orange tip going on. So we want this nice neutral type of bullet-shaped inner cone. All right, we light the torch with the flint lighter. Do not use matches or a cigarette lighter, and never point the torch lit toward an open flame or source of sparks. Yet again, we're dealing with something that's combustible. We want to make sure that we're not setting anything on fire. Make sure your area is clear of anything. If the furnace is in the garage and there's tons of gas containers around, I would not light that torch up. All right, make sure your environment's clean. The other tidbit too is if you are going to be using a torch, make sure you don't have a fire detector or a smoke alarm above the unit, or a sprinkler head, something like that. We want to make sure that if something does happen, that thing isn't going to get automatically set off just by us potentially brazing. Okay. When we're using solder, all right, actually let me backtrack here. When we're brazing, we're creating high heat, so the advent of using solder and stuff like that is not needed. So when we're using, flux, I should say. When we're using, when we're soldering, we have to prep our piping, okay? We have to make sure that our piping is going to stay nice and clean. If we start to apply heat to our copper for soldering, it's going to start to discolor, and we're not going to be able to bond two pieces. So what do? Well, we're going to apply a flux. It's a type of paste that goes to the inside and the outside of the fitting of what we're trying to solder. It's going to keep it nice and clean. So when we do apply heat to it, the solder will actually bond to the areas. All right. The way we apply heat, let me check the next slide here. Yep, perfect. We're going to apply flux to the copper. We're going to make sure that, actually even before we apply the flux, we want to sand everything down. All right, we're going to make sure that we have nice and clean copper. All right, sometimes you can use that brush, we can use emery cloth, whatever the case may be. The area that's going to have heat and solder applied to it has to be clean. So we're going to apply a little bit of flux to it. We're going to put our fitting on, and then once we do that, we're going to start to apply heat to the fitting itself. We're not applying heat or trying to touch the tubing over here. We're trying to put it on this fitting. Why? Well, as we start to apply heat to the fitting, all right, the heat is going to naturally just want to transfer over to the other pipe. So we're not going to put our hands here or anything like that. But what ends up happening is as we start to apply the solder is actually going to start to get sucked in. All right, there's a capillary action. All right, it starts to suck the material in and starts to fill the voids. So in reality, as we start to apply this heat, we're moving it around. We take our solder and we keep dabbing it until we start to see that the solder melts. Once the solder melts, we know that our piece is going to be hot enough. Literally, I would just start to slide the solder all the way around. I remove the heat, slowly apply it all the way around. Once I do that, it'll start to fill in all the voids and make a nice tight joint. All right. When soldering, be sure to wear eye protection with a number 2 filter lens or darker. All right. Brazing, it's similar to soldering, but at a higher temperature. The difference being is we don't have to use flux here. All right. The temperatures get so hot that any impurities or anything like that aren't going to matter, and we just sort of burn them all away. And so then we use a filler rod at a 30 to 45 degree angle, and we're slowly going to apply the heat, move the torch until the filler rod melts. Once the filler rod melts, it's going to create a nice capillary action, and that's going to get sucked in, just like the other one did when we were soldering. When we're using brazing rod, we want to make sure that we do have a lot of silver inside there. For refrigeration work, we want a 15 to 45% silver. All right. The reason being is silver is going to melt. It's going to fill in all the voids that we have here, whereas with solder, it's just not strong enough for the application, especially with the high pressures. Okay. The higher the silver content, the easier it is to solder. One other thing too, when we are brazing, we want to make sure that we don't have impurities that get into the inside of the copper tubing. All right. So if we start to heat copper tubing, it's going to start to discolor, and we're going to start to see that. And the problem is that not only do we have that discoloration that's on the outside of the tubing, but we have it on the inside as well. So it's sort of like a carbonization of that tubing. All right, that stuff will just sort of flake off. And as it flakes off and it's inside, well, it can potentially cause a restriction. All right, we get these little black chunks that fall off, and they may plug up a TXV, plug up whatever. And so in order to keep that from happening, we're going to flow nitrogen through there. All right, the constant steady flow of nitrogen flowing through our tubing is going to just sort of keep all those impurities from being able to build up in that space, and it's going to keep that copper nice and clean for you. All right, so make sure whenever you are brazing outside of a classroom setting or putting in a unit, that sort of thing, we want to flow nitrogen through it. Okay. It's advisable to wear number 4 darker filter lens during brazing. Brazing much higher, so we may want some darker eye protection. All right. Purging removes air, vapors, dirt, and moisture from the tubing, and it's required before brazing. All right. So what we're going to do is we're going to use nitrogen. We're going to flow that through, and we're going to push any junk that's in there. So we're talking about air. Air, any other contaminants, potentially moisture that's inside there, whatever. We're getting that all outside the tubing, and then we're going to continue to let that nitrogen flow through at a 1 to 2 psi. Okay. All right, just a couple of ways of brazing. Okay. Here's a good design. Basically what this is, it's called a swage. All right, what we have here is we've got a copper tube that's the same size as the one that it's going into. And what we do is we actually expand the outside walls of the copper tubing so that the other piece can go inside of it. And the reason for that is we want to minimize how many braze joints we have. If I have a coupling, I'll have 2 braze joints for 1 fitting. If I have a swage joint, well, the one pipe fits into the other pipe, and I just make my braze connection, and I'm good to go. The filler metal fills in all the way around. I have a nice tight connection. All right, here's just another example of that. All right, we've got the smaller pipe sort of coming down into a smaller one. I've got brazed area here and here for the filler metal. We're good to go. Poor design is this. All right, the tubing is too tight, and it just won't fit any filler material inside there. I can't fit any filler material inside there. It's not going to hold very well, and I may have a leak. So we want a little bit of a space in between for that filler metal to flow into. All right, so this is just another illustration of a swage connection. 1/2-inch tubing going into a 1/2-inch tubing with a 1/2-inch overlap. So this tubing on the left has to go inside the other one by at least 1/2 inch. All right, and that's going to change too as the tubing size increases or decreases. That swage may increase or decrease slightly. All right, swaging tools are actually very similar to the flaring tools, except we just have a different type of head on there, and it's going to push out the copper tubing to sort of give it like a bubbled shape so that the tubing on the left can fit into the tubing on the right. We have the manual swaging tools. We also have hydraulic swaging tools, which are really nice. Hand action, you give it a few pumps and you're done, as opposed to, yet again, 5 minutes of hell trying to use a swaging block. All right. We also have tube couplings. All right, we use to join aluminum tubing to copper tubing. I've never had to use these before, but they are used for dissimilar metals. All right, we're trying to keep electrolysis from happening and causing corrosion, and so we have to use something that is going to keep the electrolysis from traveling from one body to the other. All right, so we use this type of mechanical fitting. Basically, we've got this seal ring with an O-ring. This will push or tighten into the body, which then compresses everything and creates a nice tight seal. And we do the same thing on the copper tubing. Okay. Yet again, never had to ever use this guy, but it is out there. One of the other thing too that I showed you guys on the video was the press fittings. You really, those are really nice because all you do is you put the copper inside of a fitting, you press a button, the jaws clamp down onto the fitting, and you make a nice tight seal. There's also fittings out there called shark bite. Shark bite is just really, it's a push connect. So these little teeth inside there that grab onto the copper make a nice connection. So I can have this body sort of like here, shark bite coupling. We would take the copper, push it in on one side, push it in on the other side, and I'm done. It's as simple as that. They've actually come out with the same type of application for refrigerant fitting. So if you can't braze, it's too tight of a fitting, too tight of a space, that sort of thing, you can literally push fit it in and it works. Connecting pipe. All right. We want to use the pipe dope again on the steel pipe, plastic pipe, same thing. These threads may not be perfect, so some type of dope, some type of thread sealant on there is perfect. Okay. Plastic pipe, we're going to solvent weld it, which means that if we're going to connect two pieces of PVC, we're going to apply a primer to it, and then we're going to apply a glue. The glue is going to sort of melt the two plastics together and create a nice bond. All right, so once we bond them, the PVC, that's it. We're not going to undo them. Whereas with threaded connections, we could always tighten or loosen. All right, so here's just some fittings that we use for steel pipe. We have a 90-degree elbow. Some people are going to call it a 90, some people call it an elbow. Just the terms can be used interchangeably. Coupling, all right, we're going to use to join two pieces of pipe together. We've got a reducing coupling. We're going to have one size that's larger than the other. And so if I want to go from like a 3/4 to a 1/2 inch, I would use this type of fitting. I have a 45. They call it an elbow. Usually it goes by a 45. We have a T. A T, we can have 3 directions now. Usually if we're going to use this, we're going to go from one pipe and then we're going to expand it into 2. These can come with reducers on there built in, so I can have 3/4 on one side and 1/2 inch on the other, or 3/4, 3/4, 1/2, whatever the case may be. And then we also have a street elbow. The reason it's called a street is because we do have male fittings on one side and female fittings on the other. So if I have a tight little space that I need to get into or put these on, they're perfect for that. They do tend to leak, so I do know that these may be frowned upon if you are getting an inspection or something like that. So if you cannot use a street elbow, that's great, but these do exist. They come in a street 45 as well, so be aware of those. So if we're going to cut plastic piping, there's the fine-tooth saw. We can use a hacksaw. Sometimes we have to use a saw to cut through larger piping. There aren't little tools available, so it is what it is. It's not as critical on PVC as it is on copper. I would never use a hacksaw on copper. Okay, we would use a fine-tooth saw to cut PVC. We can use a miter box, and we can use pipe cutters. All right, I like the pipe cutters. They're usually ratcheting type, meaning as you click or squeeze on it, it's going to click and hold its position, and you're going to constantly press down and click down until eventually the blade cuts through the tubing or the PVC. All right, it cuts the pipe end square. We want to remove the burrs. If there's any burrs in there, if we're using a saw, there's going to be a bunch of fuzzies at the end of the pipe. We want to remove those. All right, make sure that we don't have these fuzzies in there, because yet again, those fuzzies can potentially cause a blockage or something. Okay. All right, a couple of different types. All right, when we were talking about copper tubing, we had different thicknesses. We had the type L, we had the type K. Same thing applies to the plastic. We have a schedule 40, and we have a schedule 80. Okay. Schedule 40, it's too thin to be threaded. It's always going to be solvent welded. Schedule 80 can be threaded or solvent welded. Most applications for us, it's going to be schedule 40. If we're talking about furnaces, that sort of thing, we're going to use that and call it a day. Solvent welding, all right, we're going to use a primer, which is going to clean and soften the bonding surface. We're going to use that on both the pipe itself and the inside of the fittings. The pipe is going to go inside fittings. And then once we have it primed, we're then going to apply the adhesive or the glue to it, and then it's going to dissolve part of the plastic pipe, creating a nice, strong bond. Okay. Once you do apply the solvent to the pipe, you've probably got a good 5 to 10 seconds of workability with it. So we're going to spin the pipe about 1/4 of an inch or so just to get that glue to bind, and then we're going to set it into the position that we want. We're also going to hold that for about 30 seconds until everything starts to bond. All right, after 30 seconds, we're all set. We want to make sure that the solvent and cement must match the type of piping and fitting used. So for example, if I have PVC cement, I can't use that cement for CPVC or even ABS. You know, they're not interchangeable, so we have to make sure that we're using the right combination for the right application. And that's it, guys. So we just covered all of Chapter 8 on tubing.